Okay, so I've printed off the problem that you had on the last slide, but if you just want to show your work along with me in your notes, it'll be something that'll be helpful to go back when you practice this later on in this lesson and then in next class's lesson. All right, here's how I always do this. So I'm on a road traveling at 35 miles per hour. An ambulance approaches me from behind. Now, I always harp on pictures, but it's really so helpful to draw a picture in this case, right? So it says I'm on a road traveling at 35 miles per hour. So I'm going to draw my car going 35 meters per second. And an ambulance approaches me from behind traveling at 42. So it approaches me from behind. So it's going this way, right? It's approaching me, it's coming towards me, but it's behind me. Now, the next thing that I usually do to solve a problem is I think about who is the source and who is the observer. Well, this is saying that the siren is coming from the ambulance. So the source of the sound is the ambulance. So I'm going to label this S for source. I'm going to label me O because I'm the observer, right? Because then I can go ahead and do some knowns and unknowns, like saying that the velocity of the source now is 42 meters per second. The velocity of the observer is 35 meters per second. I know the speed of sound, which as long as I'm in air is always the same, 340 meters per second. At least if I'm in air around room temperature, and that's what we're going to deal with in this class. And the sirens emit this frequency, so that's the frequency of the source is 890 hertz. Now I'm trying to figure out what frequency do I hear. So those are my knowns and unknowns. Now, doing these problems is just a little bit different because of those pluses and minuses. So I want to go ahead and I'm going to write out that equation that was on a couple slides ago. Frequency equals frequency of the source times the quantity V plus minus velocity observer, V minus plus velocity of source. And what I'm going to do is I'm going to think about, in this case, this is why the picture is so important. The source is traveling toward the observer. So the velocity of the source is toward. But the observer is moving away from the source. So the velocity of the observer is away. Now, remember on that slide we said toward means top sign and away means bottom sign. So this source is going toward. That means I'm going to use the top sign, which for the source, the top sign is minus. Right? And I usually just circle that to help myself out. But the observer is going away, and away means bottom sign, and away up here, the bottom sign is also minus. So in this particular equation, I'm using minus both times. Okay, so what do I have here then? I'm going to have the frequency is equal to the frequency of the source, which was 890, times 340 minus 35 divided by 340 minus 42. And then it's just a matter of entering into your calculator. If you don't have a scientific calculator or aren't sure about it, we can kind of do some order of operations. So we can say 340 minus 35 is 305. 340 minus 42 is 298. So I have 890 times 305 divided by 298. So I'm getting that it's 910.9 hertz. That would be the frequency that I hear. Sorry. Now, how does this change if I come over to the side of the road and come to a stop? Right? So now what I can say is, so now I'm not moving anymore, so the observer is stationary, but the source is still coming behind me at 42. In the original version of this problem, I had you also figure out what happened once the ambulance is passed, but I'm trying to just get the keys. Just break this down to its simplest form. So with this time when I do F equals Fs, V plus minus VO, V minus plus Vs, this time some people ask me, well, if the observer is not moving, is that toward or away? Well, it doesn't matter because if you add 0 or you subtract 0, it's the same thing. So you can pick whichever sign you want here. I'm just going to circle the whole thing. And then the source is still going toward us, and toward is a top sign. So when I plug this in, I've got 890 times 340, either plus or minus 0, but it's 0, so it doesn't mean anything, right? And then I've got V minus, sorry, I've got 340 minus 42. So this is 340 divided by 298. And I'm getting 1015.4 hertz. I want you to notice a couple things about our answers, right? In both cases, we heard a higher pitch, which makes sense because the ambulance is coming towards us, right? But this pitch is not quite as high as this pitch, because in this pitch, I was running away from the ambulance. But in this case, I'm not running away from the ambulance anymore, so the ambulance is fully coming towards me and I'm being stationary, so there's more of a Doppler effect in this case.